Alright, so today we are talking about ratios and proportions. So our I can statements for today are I can write ratios and I can solve proportions. Today we have a slew of new vocab words. Kind of headlining those, or what I would draw attention to, would be ratio, which is the relationship between two values. We talked about this kind of briefly with special right triangles. We didn't really go into that, but those operate on ratios. Ratios are used for a lot of estimation. So, like, let's just say, well, I spend $100 a month on food. How much am I going to spend for 12 months? So I spend 100 for 1 month equals how much for 12 months. So I guess that would technically be proportion, but ratios operate in that way, essentially. It's a way to compare and a way to predict. So extended ratios are when you're comparing more than two quantities. These aren't very common. I wouldn't worry too much about them. Proportion is a ratio that says two values are equivalent. Like that example I just said where, okay, if I spend $100 this month on food, then over 12 months, I'm probably going to spend $1,200 on food. So proportion is really anytime you have that equals component in there, making it an equation. Extremes and means. So extremes are the values in a proportion that are furthest apart, and the means are the values in a proportion that are most similar. So, like, if I had, let's just say, 1/4. You know what? Let's do it this way. So if I had 1/4 and I was comparing it to, let's just say, 3/12. My means would be these two values in red that are most similar, and then my extremes would be 1 and 12, my ones that are furthest apart. So means in red, extremes in blue, which kind of seems the opposite of what it would be based on color theory and everything, but whatever. This isn't color theory class, this is math class. So cross products. Cross products is a method for determining if a ratio is proportional. So we have already done some of this year, and we'll oftentimes use this. It's typically in two different settings. So utilizing this same example from up top, we could cross multiply, and we could say, okay, 3 times 4 is 12, 12 times 1 is 12, 12 equals 12. So yep, that checks out, it's proportional. The other spot we would see this often used would be like 3/4 equals x over 24 or something like that, where we would cross multiply to solve this. We would do 3 times 24, which would be 72, equals 4x, and we would find out that x equals 18 by solving that. So cross products or cross multiplication, this one is kind of a big deal. We use it a lot. However, you should be familiar with it already. So I don't know if it's really necessary as a vocab in your notes situation. So let's get into some example problems. So, school. The number of students who participate in sports programs at Central High School is 520. So 520 sport peeps. The total number of students in the school is 1,850 students. I don't have any witty name for them. That's a big school, 1,850? Seems like a lot. So what would that be, like graduating class of 400 plus? That's wild. That'd be a lot of people. So find the athlete to student ratio to the nearest tenth. So I said our sports peeps are up top, or our athletes, as they call them, and then our students on the bottom. So in order to get this as a to 1 ratio, we need this bottom number to be 1. So we could do this 2 ways. We could reduce this by hand the hard way, or we could just say 520 divided by 1850 in our calculators. Confusion. Well, I guess they got it wrong in their setup, but joke's on them. So when we do this, we would get 0.28108, but they wanted it to the nearest tenth. So all we are going to say is 0.0 to the nearest tenth. So instead of 0.28, we would just say 0.3. And then we would typically give this a label, sport to student, and that would be our final answer. Yippee. So this is one that you would do on your own as we go through the slideshow in person, but just for good measure, the country with the longest school year is China with 251 days. Find the ratio of school days to total days in the year, for the year, to the nearest tenth. So we're using 365 days. I guess we're assuming it's not a leap year, so that's kind of messed up because, leap years are the best. We get an extra day and whatnot. So we plug this in. We would find out that 0.7 would be the correct answer. We would happily move on. So this problem actually bothers me a little bit, but we'll go through it anyway just to kind of show you how you would solve these. In triangle EFG, the ratio of the measures of the angles is 5, 12 to 13. So we have a ratio of 3 things. This would be an extended ratio. Find the measures of the angles. So we have to employ a couple different things here. First of all, we know triangles have 180 degrees for the sum of their interior angles. So we have, and then we have all these individual ratios. So how we would go about solving this is we would say, okay, we have 5x plus 12x plus 13x equals 180 degrees. Now, each of these individual terms represents a different angle, just like up here in this ratio, they represent an individual angle. So now to solve this, we would of course add all these up. We would get 25, 30. So we'd have 30x equals 180. We would find out that x equals 6. And they want us to find the measure of each individual angle, so we have to plug this x value back in to all of these individual pieces. So our first value is going to be 30 degrees. Our second value is going to be 72 degrees. And then our third value is going to be 78 degrees. So that's how we would go about solving this. Now, why it bothers me is a 5, 12, 13 triangle is typically associated with a special right triangle, so that could lead to confusion. But it's just my own personal grievance with the old textbook. So anyway, you would go about solving this one the same way. We have triangle ABC, and the sides are at a ratio of 3 to 5 to 7, or I'm sorry, the ratio of the angles. So that being said, we would do 3x plus 5x plus 7x equals 180. And I would like to take this moment to point out that if you can look at these three numbers and say, okay, well, 3 plus 5 plus 7 is 15, then you can skip that first step of writing it all out. Personally, that's how I typically do it. I would say 15x equals 180. I would divide that in my calculator because I'm lazy and don't like to do things longhand. I would find out that x equals 12. Then I would take this and I would plug it back into each of these individual angles. And I would say B is the answer because, quite frankly, it's the only one with 36 as an angle, so it makes it quite simple for me. All right, continuing on. So cross products property. In a proportion, the product of the extremes equals the product of the means. Fancy way of saying if you multiply the diagonal people, you get the same number. All right, so we multiply the diagonals. If they're equal, that means they're proportional. If they're not equal, then we draw a big frowny face, multiple tears, because it's not proportional, and that makes us sad. So let's look at some examples of this. This should look familiar, so I'm going to kind of move rather quickly through this. So we cross multiply, we get 6y equals 9 times 18.2, which would be 163.8. Then, of course, we would divide by 6, and we would get y equals 27.3. Cross multiplication, not that bad. One of my favorite tools, actually. So, continuing on, we would do the same thing with this one. So we would do 3 times negative 26, which would be negative 78, and that would equal 6 times 4x minus 5. Now, on this 6 times 4x minus 5, be careful because you are multiplying it to that whole piece there, so you do have to use distributive property. It's a very common mistake I see. So 24x minus 30 equals negative 78. That was a nice negative sign there. So we would go about solving this, and we would say 24x equals negative 48, aka x would equal negative 2. Yay, maths. All right, so this one you would try to solve on your own, and by try to solve, I mean you would successfully solve because you're all math rock stars. So we would get 42b equals 14 times 13.5, which would be 189, and everyone knows 189 divided by 42 is 4.5, clearly mental math, also known as calculator, sitting right next to me. All right, then we would do this one as well. Once again, this is one of our tricky ones where we do have to use distributive properties. So we would do 2 times 7n minus 1, or 14n minus 2 equals 8 times 15.5, which would be 124. Add our 2 to both sides, get 126 equals 14n. 26 divided by 14, which would be 9. There we go. Yay. Happy, happy, happy. All right, so Monique randomly surveyed 30 students from her class and found that 18 had a dog or cat for a pet. So if 18 out of 30, so 18 pet folks out of 30 students, and if there are 870 students in her school, so 870 students in her school, predict the total number of folks with pets. So I just set up this proportion. Now, I do want to draw attention to one thing. So if you notice, I put the people with pets up top, and then I put your common everyday students that were surveyed on bottom. So it's important to keep these in the same relative position. So we have 18 people with pets over the 30 total people surveyed. So we're trying to predict, out of a total of 870 students, how many people would have pets. So we want to keep our pet people on top, and we want to keep our total surveyed on bottom. So we want to keep those relative, we want to kind of match up our labels, which we've talked about this before. You want to keep your labels in the same relative position, just like when we did proportions previously. You want to keep your little sides on top, your big sides on bottom in both places, or else you'll get a messed up answer that's just not even relatively correct. So solve this, we would of course cross multiply, so we'd get 30x equals 18 times 870, and then we would go ahead and divide this by 30, which was 15.15660. We divided by 30, and we found out that x would be 522. So we determined that about 522 would have creatures at their homes. At least that's our prediction. Now, we're predicting with proportions. That doesn't mean that if you actually surveyed all 870 people, that is the exact number of people who would have cats or dogs, which I'm sure you all get that, but, just really sell the point home. All right, so Brittany randomly surveyed 50 students and found that 20 had a part-time job, so 20 out of 50. And then if there are 810 total students in Brittany's school, predict the total number of students with part-time jobs. So once again, we set this up, we cross multiply, and we would find out that, oh no, I messed up my calculator. There we go, much better. 324 students have part-time jobs. All right, so our final little concept is equivalent proportions. We've talked about this previously, so I'm not going to go too in-depth with it, but essentially what this is showing is that as long as you keep things in the relative same position, then it's still proportional. So as an example of this, let's use this one from the previous problem. So I had 20 students with jobs over 50 total. And then we set that equal to how many total? 810. 810 total. And then we solved for 324 people with jobs that we predicted. So if we cross multiplied each of these, we would get they would equal each other. They would both equal 16,200. Now, what this equivalent proportions is essentially saying is that as long as we keep things in the relative position, so if we changed it and we said 50 over 20 equals 810 over 324, then that would still be fine. It would still equal out. And likewise, if we said, okay, 20 over, we could also say 20 over 324 equals, so our small group with jobs over our big group with jobs is the same as our small number of people over our big number of people. So essentially what this is saying is, as long as you keep your labels in the same relative position in the proportion, then your proportion will still ring out true. So that's just equivalent proportions, which we talked about that back with mid segments and writing our proportional pieces in triangles and parallel lines. If you have any questions, let me